Hello, everybody. Who wants to learn about the domains of life? Well, I do, Dr. K. Let's go. So, there is, of course, a three-domain system that much more accurately reflects life's history than the five-kingdom system. Okay, because the three-domain system grouped all prokaryotic organisms together. And this guy, Carl Woese, laid the groundwork for this. He discovered that prokaryotic organisms were two very distinct groups, bacteria and archaea. So based on nucleotide sequences of ribosomal RNA. So they're very different. So here's a bacteria, and here's an archaean. Okay, and the archaeans are kind of very ancient bacteria. They have peculiar characteristics. They can survive in very, very extreme conditions, and normal bacteria are just bacteria. Okay, so despite superficial similarities in their appearance under the microscope, bacteria and archaea differ at the very most fundamental molecular level, which indicates that they branched off as two separate domains very early on in the development of life. Okay, lots of intrinsic differences. They differ in the chemical composition of their cell walls. They differ in the structure of their RNA polymerases. Okay, and so bacteria and archaea are no more closely related to one another than either one is to a eukaryote. As a matter of fact, eukaryotes are more closely related to archaeans than bacteria and archaea are related to each other. What do you think about that? So, the tree of life split into three parts very early in the history of life, long before the appearance of plants, animals, or fungi, or any multicellular eukaryotes. Okay, so the modern scheme that divides life into three domains. We've got bacteria, archaea, and eukarya. And again, these two are more closely related than the bacteria and the archaeans. So here's the tree. Oh, there's my tree. So here was the split. Here's the common ancestor of all life, that very first cell. And then the bacteria branched off early on from the archaeans. And then the archaeans and the eukaryotes have a common ancestor here. So again, they are much more closely related than the other two are. All right. And you'll see here, and again, based on this is sort of a tree-shaped cladogram, based on how they are arranged on the evolutionary tree, animals and fungi are the most closely related, then plants, and then our protists, which are unicellular eukaryotes. Okay, so within the domain eukarya, there are four groups: Animalia, Plantae, Fungi, and Protists. Okay, we are animals. Okay, plants are plants, fungi are fungi, and protists are eukaryotic organisms that are not animals, plants, or fungi. Most of them are unicellular, but not all. Like giant kelp is a protist, and it's giant. It's not unicellular. And here is an evolutionary tree, a cladogram, if you will. Cladogram. Okay, here's our common ancestor of everybody. Animals, we are down here, of course, our closest relatives, the fungi. And then we have some protists, amoebas. Then the plants. Okay, then here's some more protists. And actually, the rest of these are all protists. There's a lot of protists. A lot of protists. Okay? So that's kind of how we all fit in together. That's it. The end. Those are the domains of life.